Lesson 2-10, change expressed as a percent. So we're still doing proportions, we're still talking about percents, but now there's going to be some type of change that you'll have to express as a percent. All right, so when you have a new amount, if the new amount is greater than what the original amount was, say for anything, that percent change is a percent increase, okay? And if the new amount is less than the original amount, then obviously that is a percent decrease. So there's a formula for finding percent change. It's kind of similar to our is over of equals percent 100. This time it's change over original equals percent over 100. So remember, this is when you're finding how much something changed. Change over original equals percent over 100. Let me show you how to use this formula. For example, a coat is on sale. What is the percent of change? So this is the original cost, $82. The new sale price is $74.50. Is that a percent increase or decrease? Well, the original was 82 and obviously the price went down. So this is a percent decrease. All right, so to find how much it did change, we have to find out that actual value of change. So you don't put the new amount in. That's what a lot of people think. You actually find the difference from the old to the new. So you want to take $82, subtract $74.50. You get $7.50. So that's how much it changed. That's what you put on the numerator. Then you put it over the original amount. Well, that was 82. So 750 over 82 equals percent over 100. So we're solving for percent. So now I'm just cross multiplying and dividing by 82, and I get 9%. Okay? Let's try another one. A store buys a guitar for $295, and they mark up the price to $340. What is the percent of change? All right, so this is what the store bought the guitar for. This is how much they're selling it for. Since it increased, that is a percent increase. So how much did it increase? We're trying to find the percent. I need to find the difference from the original to the new. And you're always finding the absolute value of this change. So I'm going to take 295 minus 340. Since that will give me a negative number, 295 minus 340, you get negative $45. We're just going to put a positive 45 because you want to use the absolute value difference. Another way to do this is subtract the smaller number from the bigger number, and you'll always get a positive answer. So it changed by 45, whether that went up or down. The original amount was 295, and we set that equal to percent over 100. When we cross multiply, 4,500 divided by 295, I get about 15%. So I'll just do one more example. Original price is 96, the new price is 78. My formula is change over original, so I need to find out how much this changed. I'm going to do 96 minus 78. I get 18. Put that over my original price. Set that equal to x over 100. I'm solving for percent. 1800 divided by 96 is 18.75%. So in the second example, when I'm finding the change, it's okay to start with the new and subtract the original amount, 127 minus 59. So I get 68, because you always want your change to be positive. You're finding the absolute value of that. Okay. Another concept they'd like you to know is how you can use percents to compare estimated or measured values. So, relative error, this is the new vocab word, is the ratio of absolute value of the difference of a measured value and an actual value. Okay, so if we are going to measure something or estimate something, we want to know the relative error. How far can we be off? Okay, this will make more sense when we get into an example. So when relative error is expressed as a percent, it's called the percent of error. Okay, how much were we wrong in our answer? To find the percent of error, you're going to take again the absolute value of the estimate minus what the actual measurement or whatever it was you were finding, and then you're going to put that over the original, set equal to percent over 100. So that's the formula for percent error. Now let's use this formula. Finding percent error. A decorator estimates that a rectangular rug is 5 by 8 feet. The rug is actually 4 feet by 8 feet. What is the percent error in the estimated area? Okay, so this is the estimate, and if I move this down a little bit, this is the actual. So the actual was 4 by 8. They were off by one number. Okay, well, I need to find the area. So the estimated area is 5 by 8. That gives me 40. And the actual area is 8 by 4, so it should have been 32. So to find the percent error, absolute value of the estimated answer, which was 40, minus the actual, which was 32, put it over the actual again, and that will equal percent over 100. So 40 minus 32 is 8. 8 over 32 equals x over 100. 800 divided by 32, I get 25%. So the estimated area is off by 25%, is how you think about that. Let's do another example. You think the distance between your house and a friend's house is 5.5 miles. So the estimate, 5.5 miles. The actual distance is 4.75 miles. What's the percent error in your estimation? So our formula, find the difference between the two. 5.5 minus 4.75. And I get 0.75. Put that over the actual amount, 4.75, and set that equal to percent over 100. Now I'm going to do my proportion solving, divide by 4.75, and I get about 15.8% error, or about 16%. So you find the difference, put it over the actual, and set that equal to percent over 100. All right, 2 more examples in our lesson. Finding minimum and maximum dimensions. So when we measure, when we use rulers, tape measures, there's always a chance that we can have human error and measure incorrectly. So the most any measurement should be off by is half of the unit that you're using. So if I'm measuring something in inches, I can be about half an inch off. Okay, so half of whatever the unit is you're measuring in. Okay, so say you are framing a poster, you want to put a frame on it, and you measure the length of the poster as 18.5 to the nearest half inch. What are the minimum and maximum possible lengths of the poster? Okay, so right away we're measuring in half inches. So our error can be half of that, 0.25 inches. That's how much error we can have since we're measuring to the nearest half inch. Okay? So, to find the minimum dimension that I could possibly have for my frame, because you want to take into account your human error and you don't want your frame to be too small or too big. So the minimum length, I'm going to take what I got for a measurement, 18.5, and I'm going to subtract this amount of error, 0.25. So I get 18.25. I'm going to go on to the next problem here. For my maximum measurement, I'm going to take what I had, and I'm going to add my amount of error. So now I have 1875. So go back to the question, what are the minimum and maximum possible lengths? My minimum is 18.25 inches, and my maximum is 18.75 inches. So that answers the question. I'll do another example. A student's height is measured as 66 inches to the nearest inch. So we're measuring in inches so that I can have air up to a half of an inch, half of my unit. What are the student's minimum and maximum possible heights? So they measured something in 66 inches. Well, my minimum, I'm going to subtract my 0.5 inches, and I get 65.5 inches. And my max, I'm going to take 66 and I'm going to add my amount of air, and I get 66.5 inches. So there's my minimum and there's my maximum. Hopefully you took some good notes on those examples. I'm going to have you attempt problems 1 through 3. Number 1 is a percent decrease, 2 is a percent increase, and in 3 you're just finding those minimum and maximum lengths.